Hello, Mishler Math kids. Linear programming is the topic of the day, and if that blows you away, don't let it. It's really just an extension of what we talked about last time. Last time we talked about systems of linear inequalities. You remember we had a shaded region on the graph, and all we're going to do now is we're going to write a system of linear inequalities, and we're going to come up with some very practical conclusions using that system for real-world situations. And so, for example, linear programming is widely used in business and agriculture. That's why I want you to learn this. Some of you guys are going to be going into business. Maybe some of you are going to become president of a corporate farm. Who knows? But suppose you have a farm. You're going to grow crops. Now, here's what, now this is from America, of course, so this is what, there's some guy named Max, all right, from 96, these are statistics that he came up with. For corn, if he grows corn, he can expect 113.5 bushels per acre. Okay, that's the product that he's going to get off of that, and he's going to sell it for $3.15 per bushel, average price, okay. Wheat, 35.8 bushels per acre, and he's going to sell it for $4.45 per bushel. So those are just some basic, and this is just a table of all these values for 6 different crops that he might grow. So this is what he wants. He's got some constraints here. He says he wants to plant according to the following constraints. No more than 120 acres of both. So he's probably just got 120 acres that he's going to be farming of corn and wheat. Okay? At least 20 and no more than 80 acres of corn and at least 30 acres of wheat. Now, some of you are able to look at this and say, yeah, okay, I see some inequalities coming up now. All right, so that's what we're going to have. So what we want to know is he wants to make as much money as he can. So how many acres of each should he plant? And this is called linear programming. Okay, the inequalities, constraints. Solution is called the feasible region, and the function is the objective function. Now, this is where it gets interesting. So we're going to go to the graph here, and we're going to start writing some of this stuff down. Okay. Now remember, we've got constraints. The first thing we're going to do is we're going to look at the constraints. And if we look at the back at the picture of this thing, he said he wants no more than 120 acres of corn and wheat. And so no more than 120 acres of corn and wheat means that x plus, let's make, x, we're going to make that the corn, and y, we're going to make that the wheat. So both of them together, x plus y, we want that to be less than or equal to 120 acres. Okay? And then we have the corn, which is x. We want that, and once again I go back here and take a look at this. We want the corn to be at least 20 and no more than 80 acres. Okay? So, by the way, acre is just a term for a certain amount of land. So, x is between 20 and 80 acres. And then wheat, it says wheat, which is y, that wants to be at least 30 acres of wheat. And so now we have, of course, a system of inequalities. So we can graph these. And I'm going to have to change my scale here. I can't go 1 to 10 and get 120 on there. So let's make this 10, 20, 30, 40, 50, and then 60, 70, 80, 90, 100 at the top. Okay? And so, and the other thing is that he's not going to do a negative number on either one of those. So we can get rid of all that. Don't worry about the quadrants 2, 3, and 4. We're just going to deal with the first quadrant. So, all right, and so let's look at this. If we take x plus y is less than or equal to 120 acres, well, then I can say y is less than or equal to a negative x plus 120. Well, 120 would be up above here. So negative x means I would be going down this way, and so right about here I think it would end up here, and I would have, ooh, crooked line again. See if I can do this. I think that this would be the line for this one, because I got x plus y is less than or equal to 120. Subtract x, you have y less than or equal to negative x plus 120. Well, 120 is going to be up above here, but it's going to be 2 units up above, and so I just came down 2 units and said we'll put it right here, because this is 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, same as the other scale. Okay? Anyway, so now I want x is between 80 and 20, because he wants in between 20 and 80 acres of corn. And so we've got x is greater than or equal to 20. So there's 20 right there. So we'll just draw a vertical line right there at x equals 20. And if you guys are a little confused at this point, that's okay. Just bear with me. It'll be okay. And then 80. 80 is right here. So I'm going to draw another vertical line here at 80. Okay. And then y is greater than or equal to 30. So I go up here to 30, and I say y is greater than or equal to 30. So you see what I've got is I've got some boundaries here. I've got a region here that if I shade this region here, and I got y is less than or equal to a negative x plus 120. That's this curve or slanted line here. It's the only slanted line we have here. So, and it's below that. X is less, or y is less than or equal to. So I'm going below that. Y is greater than or equal to 30. So I'm going above this line. Okay, and I'm going in between these two vertical lines. And so that's my shaded region right there. You notice that I've got points here that if I were to label these points, I would say this is point A, and the coordinates for A are 20, 30. Okay. Coordinates for point D or point B is up here. Okay. This is B, and the coordinates are 20 and 100. Okay. And C is right here, and the coordinates for that point, let me change color so you can read it, are 80, and because we're up at 80 here, and 40. And then D is down here, and the coordinates for D, let me put that up here, coordinates for D are 80 and 30. Okay, so that's point D. And so what does this all mean? What do I do with all this stuff? Well, I have what we call the objective function. Okay, the objective function, you say, what the heck is that? Well, let's go back and look at our thing here. You see, if he grows corn, how much is he going to earn per acre? Well, 113.5 bushels times 3.15 bushels, that's going to give him the amount of yield, dollar yield per acre that he's going to get. Okay, and so they did that for us in the book, and I'm going to save us a little bit of time and say it's right here. R equals 357.525x plus 159.31 y. That's how much he earns per acre of corn, and that's how much he earns per acre of wheat. And so let's go back to our workspace here. So what we have is the revenue that he's going to earn is 357.525 5 times x plus 159.31 times y. Now, if we do all that work, and they did that for us in the book, okay, if we do all that work, we'll have a table of values. That's we're supposed to do that as an exploration, but I'm just going to show you the table of values right here. You just figure out the value for each acre, or for each point, and the corner point principle says that you only have to look at the corner points, and that's why we did that on this. We just looked at the corner points A, B, C, and D, and we come up using this. We have an x and a y value for each one of those points. Like, for example, A, point A is 20, 30. And so we just plug in 20 and 30 for here, and we come up with a value for A. And looking back at the book, at point A, the value is $11,929.80. That's what he can earn for planting this much corn and this much wheat. And that's basically how that works, okay? And so I'm not going to waste any more of your time with that. I hope you got the general idea of what we're doing with this. And we're going to move on, and we're going to try another one. And this time, we're going to use a minimum value. And let me give you the constraints, first of all. In other words, this is the x greater than or equal to 0, y greater than or equal to 0. In other words, we're in the first quadrant, okay? And the next one is 5x plus y greater than or equal to 20. And so if I subtract 5x from both sides, I have y greater than or equal to negative 5x plus 20. And then I have x plus y. By the way, this is a system of inequalities. X plus y is greater than or equal to 12. And if I subtract x from both sides, I have y greater than or equal to a negative x plus 12. And then I have x plus 2y greater than or equal to 16. And if I do some maneuvering with this, and I'll let you do this on your own, but anyway, that equals negative 1/2 x plus 8. Just divide everything by 2 and subtract the half x from, you divide everything by 2, you got x over 2 plus y is greater than or equal to 8. So then you subtract x over 2, which is 1/2 x, and that's why you get what you get here, okay? So there's my inequalities. Now let's graph those and see what we end up with. And we got, first of all, it's going to be in the first quadrant, so don't worry about the second and third quadrants, okay? 5x plus y, it's negative 5x plus 20. So I'm going to put 20 up here and 10, or 0 here on the x-axis, so this would be 2, 4, 6, 8, 10 would be here. And then 2, 4, 6, 8, 10 would be here, and 20 would be over here. So I got negative 5x plus 20. So I put 20 up here. I go down 2, 4, 5, and to the right 1. Remember, I'm doing 2 for 1, so the right 1 would be right here. Another way of doing 5 over 1 would be, or negative 5 over 1 would be negative 10 over 2. So I can go down 10 units and to the right 2 units. And so, at any rate, there's my first line. And I'll just draw that like that. Okay. And these are all greater than or equal to signs, so I don't have to worry about anything, any dotted lines or dashed lines. The next one is y greater than or equal to negative x plus 12. So plus 12 is here, and negative x means I just go corner to corner. Got the same scale on both of them, so I just go corner to corner all the way down here. And remember, I'm only in the first quadrant, so I don't need to go too far here. Then the next one is y greater than or equal to negative 1/2 x plus 8. So here's my y-intercept plus 8. Negative 1/2 means I go down 1 and to the right 2. Or I can go down 2 and to the right 4. And down 2 and to the right 4. And so there's my line starting point here, and I don't like that, so I'm going to start over again. Starting point here, and there's my line right there. Okay, so those are my 3 lines, plus of course the axes are the other constraints. Okay, and I don't need to worry about that one. Now, the shaded region, all of these are greater than or equal to. So the shaded region is going to be all this area here. Now, obviously, I've got no maximum value because it just keeps on going infinitely far in that direction. So I'm going to worry about this point and this point and I think this point here. And what I didn't tell you before, and it's in your book, and I pulled this right out of the book, your objective function is s equals 2x plus 3y. So I just get my x and y coordinates for each one of these points at the corner points because of the corner point principle. And that's supposed to be right there. And so here my value is, let's see, 10, 20, or 12, 14, 16. X is 16, y is 0. So I got 16, 0. I've got up here, I've got 8 and 4. Up here, I've got 2 and 10. And up here, I've got 0 and 20. And if I plug these into this equation, each one of these ordered pairs, 2 times 16 is 32. So here it's going to be, my value is going to be 32 because there's no y because the y is 0. Okay. This one, 2 times 8 is 16, plus 3 times 4 is 12. 16 plus 12 is 28. The next one, 2 times 2 is 4. 3 times 10 is 30. So 4 plus 30 is 34. And the next one is 0 and 20. So there's no 0, or there's no x there. So 3 times 20 is 60. So what I'm looking for is my lowest value here, and s equals 28 is my lowest value. And so that's at the point 8, 4. And so that's the point right there. That's my minimum value. And I'm sorry this took so long, but that's how you do linear programming. We'll talk more about this in class, of course. Thanks.